Welcome to another episode of NASA Science Live, an opportunity for you to interact with NASA experts and have your questions answered in real time. I'm your host, Megan Cruz, and today we will talk about some of the extreme weather conditions we've been seeing across North America. In fact, just hours ago, NASA announced that July 2023 was the hottest month ever recorded on Earth. It was also the hottest July on record, according to NASA's global temperature analysis. If you have questions throughout today's show, you can send them in using the hashtag AskNASA on social media or drop them into the comments section wherever you're watching us today. Now, joining me now are two climate experts to discuss this record-breaking news and explain what we can do moving forward. Dr. Kate Calvin, NASA's Chief Scientist and Senior Climate Advisor, and Dr. Gavin Schmidt, Director of NASA's Goddard Institute for Space Studies. Thank you both for being here.
Thank you for having us.
Thank you.
So again, today NASA announced that July 2023 was the hottest month ever recorded on Earth. We know this and can say this with confidence because of NASA's global temperature record. Gavin, can you explain what this record is and what this July looks like in the context of that bigger picture?
Absolutely. NASA gathers information from weather stations around the globe, from ocean buoys, from ship records, from automatic weather stations, and it kind of knits it together to produce an estimate of the global mean changes over time. And we can do that accurately going back to roughly the mid-19th century. And what we've seen in recent years is ongoing global warming. But what we've seen specifically this month is that this July was so much warmer than all previous Julys. And because July itself is in fact one of the warmest months of the year globally, that means that it was the absolutely warmest month in that whole record going back at least to the mid-19th century. One of the things that we also do is we can compare that to other estimates of what's going on through what are called reanalyses, which is the weather forecast models, or directly from satellite instruments. And all of those sources of information confirm that July was record anomalously warm across vast swaths of the globe.
Yeah, and that graphic we really saw this July spike in comparison to all the other average changes we've seen in the record. How much more is this July that change than other changes we've seen prior?
So the margin by which the record was broken was over 0.2 Celsius, which is almost half a degree Fahrenheit, and the uncertainty in one of those numbers is just like 0.08. So the difference between 2023 and 2019, which was the previous record, was hugely significant.
Yeah, big difference there. So we know we have the hottest month on record. Kate, how is the rising global average temperature and the climate change manifesting in these different kinds of weather, extreme weather we've been seeing across North America?
Yeah, thanks, Megan. So climate change is more than just changes in temperature. There's other changes that we see in the Earth system, things like increases in sea level, declines in Arctic sea ice. We see changes in the water cycle, so you get more heavy precipitation events, heavy rainfalls, and in some regions, more droughts. We also see more extreme events like heat waves or wildfire. For something like a wildfire, climate change can affect both the fuel for fires, so it can dry out vegetation so that there's more that can burn. It can also produce fire weather, so conditions where it's hot, dry, and windy, and they're very conducive to fire. And climate change drives all of those. And at NASA, part of what we do is observe what's happening in different parts of the Earth system, both now and as it changes over time, so that we can study those effects and how they're changing. So for something like sea level, we have one satellite or a series of satellites that have been able to show us total sea level, so we can see how much sea level has risen all around the world. But we have other satellites that'll show us some of the contributing factors to that. So we have another set of satellites that have been able to show us changes in the mass of ice sheets. So as ice sheets melt, that water runs off into the ocean and contributes to sea level rise. And we're able to see those effects of climate change and how they're changing over time.
So we have a lot of opportunities to track the effects, but then what are the causes, and how has NASA identified those causes?
Right. So NASA is keeping track of the causes of climate change too, whether that's changes in greenhouse gas concentrations, changes in the activity of the sun, changes in the stratosphere because of volcanic effects, changes in the natural system, whether there's an El Nino or a La Nina. NASA is looking at all of those different elements as well. Atmospheric pollution, deforestation, all of that comes from NASA data, and then we can integrate that information using climate models, using statistical models to try and piece together what the fingerprints are of any of those different changes, and then fit those fingerprints to the evidence that we have. And when we do that, what we find is that the long-term trends that we're seeing, that you saw in that earlier graph, are all due to human activity. Dominant in that is the role of greenhouse gases, carbon dioxide, methane, CFCs, and there's little roles for all of those other things as well. But the main result from that analysis is that those trends that we're seeing, that with the